Hello everyone, this is Dr. Michael from MLR Institute of Technology. We are going to discuss the topic Demultiplexer from Digital Electronics and Computer Organization. We will see the introduction, details and the applications. So, to understand this better, first let us start from the structure and how it works, and then let us look at the points. So, here based on the selection lines, the output is connected to any of the four possibilities. If selection lines are both zeros, then the output is connected here. For 0, 1 of the selection lines, the output is connected here. For 1, 0, it is connected here. When both the selection lines are 1, 1, the output is connected at the last case. So, one thing I want to tell students here, the order different textbooks take this differently. Somebody could take this as S1, S0. Somebody could take this as Y3, Y1, Y. Somebody could take this as Y3, Y2, Y1, Y0. Both are accepted. Different textbooks take them differently. So, here a data distributor combinational circuit. The input data it distributes in any of the four possibilities. Works in reverse way of the multiplexer. Demultiplexer is the inverse of multiplexer. If you look at this structure, what we have here, for the case of one input, we have 4 outputs. 4 we can write it as 2 power 2. And how many selection lines we have? 2 selection lines. So, in general, n represents the selection lines. In this case, n is 2. So, we have 2 selection lines. N signifies the number of selection lines. 2 power n represents the output. So, 2 power n, in this case 2 power 2 represents the number of output lines. As per selection line, the demux input lines will be connected to receive the output. As discussed at the beginning, if both are zeros, this is connected here. Connected. Focus on the term connected. So, now let us see how we could implement the truth table for this. So, here let us understand how we can get the expression for y0. So, y0 in this case, y0, the expression for y0 will be I multiplied by S1, S0 both in the complementary form. Okay. So, y0 will be I multiplied by S0, S1 in the complementary form. Likewise, y1 will be I multiplied by S1 bar and then S0. Likewise, this case, here we have I multiplied by S1. Because we have a 1 here, we are taking the variable in the true form. Because we have a 0 here, we have to take S1 in the complementary form. Last case, I multiplied by S1, S0. S1, S0. So, here, these are the expressions that we have for Y3, Y2, Y1, Y0. Based on that, we can construct this circuit. So, first of all, we can observe that I is the common input for all the cases. So, I is the common input for all the cases. That is the first step in constructing this circuit. Now, next, here the variables S0, S1 are either in the true form or they are in the complementary form. So, to get the complementary form, we need to make use of NOT gates. So, 2 NOT gates, one common input, 2 NOT gates we have considered. And of course, the inputs will be in terms of I and in terms of the selection lines. So inputs in terms of I and then in terms of the selection lines. Then to perform I into S0 bar into S1 bar to multiply 3 Boolean variables, we need to use 3 input AND gate. So total 1, 2, 3, 4. 4 expressions. So 4 3 input AND gates. 4 3 input AND gates. Okay. Now let us see what will be the expression for Y0. Y0 in this case is I into S0 bar into S1 bar. So where we are actually getting I here into S0 bar we are getting here and then S1 bar we are getting here. So this is actually Y0. As I told you in the beginning, somebody would consider the outputs in terms of Y0, Y1, Y2, Y3 from bottom to top, or selection lines also somebody could take like this, S1, S0. Both the possibilities are accepted. Selection lines in place of S1, S0, somebody could take S0 and then somebody could take in place of S1, S0, S0 and then S1. So that is the case here. This is actually Y0. Next case. So let us see what is the expression we are getting here. So I, of course, I multiplied by, in this case it is S0 bar, S0 bar, and then in this case it is S1. So I into S0 bar S1. I into S0 bar S1 is actually our here, okay, in this case it is actually in terms of the expression. So all you need to do is, okay, check where I into S0 bar S1 is there. I into S0 bar S1. So I into S0 bar S1, yes. So we have here, so that in this circuit, that where do we have? That we have corresponding to this. So that is the reason this is the expression for that case. So I into S0 bar S1. Now let us see the other situation. We have I multiplied here. So I again, and then what do we have in this case? Here we have S0. We have S0, and then here we have the case S1 bar. We have the case S1 bar. Then let us see the last case. So last case we have I again multiplied by S1 and then again multiplied by S0. So usually there is no issue with first and last cases. I S1 S0, I S1 S0. And I S1 S0 in this case it is given for Y3, which means this is actually taken as Y3. So no issues in terms of Y0 and Y3. It is clear. But what about these two cases? If this is Y3, this is Y2, this one has to be Y1, this one has to be Y2. Again, I would remind the audience, the previous case is also correct, this is also correct. We have multiple answers. Different textbooks represent it differently. Okay, so now, but if you look at the case of Y3, for the case of Y3, here, okay, both are in true form, so no issues. But what about this? This is Y2, okay, for the case of Y2, we have I into S1 S0 bar. but here S0 into S1 bar. So observe these two. Bar is for S1 for the case of Y2. For the case of Y2, bar is for S1. But okay, if you see here, bar is for S0. So how can we explain this? Again, very simple. The previous point. If you exchange this, you are also going to exchange these two. So this is no longer S1, S0 that we are going to consider here. This one is your S1 and then this one is your S0. Right? So now if this is S1 and this is S0, now let us see what we are going to get at different places. So both these are exchanged and then here also the bar is exchanged. Now let us see what is Y1. Y1 is I into S0 S1 bar. Y1 is Y1 I into S0 S1 bar. So now it is fine. So this is Y1 I bar we have for S1. Y1 bar we have for S1. So any of these method is accepted. The first case where this was S0, this was S1, Y3, Y2, Y1, Y0, that is also accepted. Or exchange all of this. Y0, Y1, Y2, Y3 and then these two are also exchanged. Y3 became Y0, Y0 became Y3, vice versa. The intermediate shufflings have also been taken place. Any of the cases it is accepted. I want to stress on this point. I wanted to make it clear because if you read some of the textbooks, okay, you may feel something is incorrect, but it is not. It is just a different method. So the multiplexers are used to design the ALU circuits. How? Based on the selection lines, the given signal can be connected here. Maybe you have an adder block here, or you could connect at the second case. You could connect a multiplier. At the third case, subtractor. Suppose last case, divider. The given input based on the selection lines you can pass to either adder, subtractor, multiplier, or divider. So hence it is useful in arithmetic circuits. Convert output of the mux into the actual input. So actually this is the reverse process of the mux, and that is how you can use demux to obtain the reverse process of a multiplexer. Each demux has a connection with multiple registers which can help to store the processed data into it. So what you can do, you can connect multiple registers here and then based on the selection lines you will decide where this value should be stored. Should it be stored here or here or here or this case. In audio or video system, the demux distributes them to different channels. Again, the given signal can be distributed to different channels by using the selection lines. In broadcasting, the demux separates the composite signals into individual one. So usually in broadcasting, what happens is multiple signals are combined into a single line. However, at the user end, the distribution takes place. So there again, the multiplexers are used. So we have seen the applications and also the general details about demultiplexer. That's all for today's lecture. Thank you.